This project is an independent proof of concept developed by benslaman.com. This demonstration uses generated data to simulate real-world scenarios for research and evaluation purposes. It is not affiliated with any company or organization. This narration is generated by a voice model running inside the same cluster managed by the SCCI router. This demonstration presents SCCI. SCCI stands for Smart Cognitive Cluster Intelligence. SCCI is an adaptive system. It routes AI workloads across a cluster of heterogeneous devices. The SCCI router analyzes request intent. It evaluates session context. It checks available compute. Then it decides where each task should run. Each node has a preferred role, but roles are not fixed. The system can dynamically reuse any node when needed. This creates a model where computation is orchestrated across the cluster. Now observe how the system behaves during this demonstration. The system is already initialized and ready. Attention is all you need. A chat request starts on the edge. The SCCI router evaluates intent and cluster state. It begins on a lightweight node to keep resource usage low. If the conversation grows, the system steps up only when needed. Helper and direct response. For structured tasks, the system switches lanes. The SCCI router routes the request to a helper node. In some cases, the router can respond directly. No model invocation is required. This reduces latency. It preserves compute resources. We can see in the logs that the router splits the request into multiple intents. The greeting is handled on bphone 0, while the time query is processed on bphone 2. The result is returned directly from the tool without using a language model. This shows efficient, distributed routing across specialized nodes. In this test, a large document is sent for summarization. The router detects the long context and escalates to a higher capacity node. The input is optimized, processed, and summarized seamlessly. This demonstrates context-aware routing and dynamic scaling. We can see in the logs that the request starts on bphone 0. As the context grows, the router predicts a capacity limit and triggers a handover. The request is transferred to bphone 3, where processing continues seamlessly. This demonstrates predictive escalation and context-aware routing. In this scenario, the system receives an image and a request for description. The SCCI router detects a vision task. It selects a vision-capable lane on shared compute. This demonstrates multimodal understanding across the cluster. We can see in the logs that an image is detected. The router switches to the vision lane and isolates the input. The request is then routed to BGPU 0 for processing. The image is analyzed, and the result is returned to the user. In this scenario, the SCCI router detects a programming-related request. It selects a dedicated coding lane for code-oriented processing. We can see in the logs that a coding request is detected. The router switches to the coding lane and routes the request to BCPU0. Only the latest input is used, ensuring efficient processing. This demonstrates optimized routing for coding tasks. For this task, the router selects a lightweight, specialized coding model on BCPU0. There is no need to use a GPU or larger models for this type of request. This approach reduces resource usage while maintaining efficient performance. By matching the task with the appropriate model, the system avoids unnecessary compute and optimizes overall utilization. In this test, we trigger an image generation request. The SCCI router detects a multimodal intent. It first selects bphone 3 as the preferred node. The image is generated successfully on bphone 3. Now, we simulate a node failure by putting bphone 3 in airplane mode. The router detects that the node is no longer available. A fallback is automatically triggered. The request is rerouted to an alternative node, such as BGPU 0. After fallback, the request is completed on BGPU 0, and the image is successfully generated. We can see in the logs that after the fallback, the system continues to monitor context usage. As the request grows, the router predicts another context limit. A new handover is triggered, this time to BCPU 0, increasing the available context capacity. The session remains active, and processing continues without interruption. This demonstrates that the router not only handles failures, but also continuously adapts to context requirements in real time. The SCCI Lab Router also integrates voice capabilities through a dedicated audio generation node. This node converts text responses into speech using a text-to-speech engine. Speech recognition is handled separately by a whisper-based service. From a telecom perspective, this component can be compared to the Media Resource Function, or MRF, used in IMS architectures, which provides media services such as announcements and audio processing.
I am the SCCI Router, a telecom-inspired cognitive control plane for AI workloads. I analyze each request, classify it by intent, and route it to the appropriate model and node. I start with lightweight devices and escalate only when necessary. SCCI stands for Smart Cognitive Cluster Intelligence. It represents the decision layer of the lab router, responsible for classifying incoming requests and routing them to the most appropriate model and compute node within the cluster. Its goal is to coordinate specialized inference nodes and select the best resource for each workload. The router selects models and inference nodes using a multi-stage decision process based on intent, context size, and available hardware resources. First, each request is classified through an intent matrix, which determines the appropriate processing lane, such as chat, coding, vision, or tools. A strict precedence ensures that specialized workloads, like vision or code, are routed before general chat. Once the lane is selected, The router chooses the smallest capable model using a ladder strategy. Lightweight nodes, such as phone-based devices like Bfon A0, are preferred for simple tasks. If the request requires more capability, the workload can escalate to CPU or GPU nodes. The system also maintains session continuity, avoiding unnecessary node switching and preserving context efficiently. For coding tasks, the router behaves like a tool by sending only the relevant user input instead of the full conversation, improving performance and latency. This approach allows the system to balance performance, resource usage, and energy efficiency while maintaining consistent and predictable behavior. You are seeing a telecom-inspired cognitive control plane for AI workloads, not just a chatbot.
The cluster is not statically partitioned. Nodes have preferred roles, but they can be reassigned dynamically. This allows the system to adapt to load, availability, and workload evolution. The result is a flexible and resilient inference fabric.
You're very welcome. I'm happy I could help. Let me know if you have any more questions or scenarios you'd like to explore.
SCCI is not just about running models. It is about orchestrating where and how computation happens. This demonstration shows how distributed AI models operate as a coordinated system. Instead of relying on a single model, the system dynamically selects the best execution path. Intelligence is not just about bigger models. It is about better orchestration. This project is an independent proof of concept developed by benslaman.com. This demonstration uses generated data to simulate real-world scenarios for research and evaluation purposes. It is not affiliated with any company or organization.